We are going to be taking a look today at two-digit subtraction using the magnifying glass strategy as well as a chip model. Let's begin by looking at our learning target for this lesson. I can use the manipulative representations of two-digit subtraction to transfer knowledge and apply it to the written form. Okay, manipulative representations are examples like place value discs that we have been using to show the differences in our place value units. Well, we are going to transfer that knowledge from the hands-on part of our manipulative representations, and we are going to be drawing to help us solve problems. Let's take a look at 31, take away 18. All right, so what is the whole in this subtraction problem? Right, 31. The greatest number is the whole. Taking away 18, 18 is one of the parts. What are we trying to find or solve for? Yes, the missing part. So 31 is the whole. Take away 18, one of the parts. The answer will give us the missing part. Because we know when we're adding, we add two add-ins together. Part plus part equals the whole. Let's take a look at the 31, the whole. Okay? Just like when we become detectives in our science curriculum, okay, a lot of times we use hand lenses or magnifying glass so that we can look carefully and make sure we're not missing anything. Well, we are going to apply that information today to looking at our subtraction problems. So I want everyone on their interactive whiteboard to draw a magnifying glass over the whole 31. We are going to use dots or chips to represent what we have been doing with place value discs today. So when we take a look carefully with our magnifying glass at the whole, okay, we are going to be able to show using chips just the whole on our place value chart. So on your personal whiteboard, okay, you should already have your place value chart. It may be labeled or unlabeled to show the place value units. Either is fine. Okay, let's really look carefully with our magnifying glass. How many are represented in the ones digit? 1, very good. So we're going to put 1 in the ones place. Let's look carefully how many tens are represented. Right, we have 3 tens in the tens place. So let's go ahead using our chip model and put 3 tens. Take a look at your board and compare it to the screen. Does yours look the same as mine? Fantastic. Now, we do know that we need to take away 18. And so we are going to carefully show that on our place value chart. But when we look at the smallest place value, which is the ones place, okay, we have to stop and think. Wait, can I take away 8 from 1? I don't have enough, so we're going to need to unbundle or decompose a 10. So using our chip model, we will be able to show this, okay? So we're going to take a 10 and we're going to decompose or unbundle, and we're going to use a 5 group to show 1 10 is the same value as 10 ones. So notice we took a 10, we unbundled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we will be able to show on our standard algorithm or the written form right here, we'll be able to show exactly what we did on our chip model. Okay, so let's take a look. The first thing we did was stop and look at the ones place, and we know we could not take 8 away. We didn't have enough. So we moved into the tens digit and we decomposed the 3 into 1 plus 2. When we did that, we were able to use 1 10, leaving us with 2 remaining. And we decomposed that 10 and put them or unbundled them into the ones place. So we're going to go ahead in our magnifying glass, 10 plus 1 equals 11. And we are going to show that within our magnifying glass because that's very important to our problem. Okay, now we do have enough ones that we can subtract 8. So let's try that on our chip model. 1, 2, 3, 4, 5, 6, 7, 8. Let's take a look carefully. We have 1, 2, 3 ones left over. Now we need to mimic that onto our written form. 11 take away 8 is 3. Pause here for a moment and make sure that your board looks like the screen. If you've made an error, no problem. Let's take some time to correct that. And let's now look at what we need to take away in the tens place. There are 1 10 that we need to take away, and we have 2 10s, so we can do that. We are going to take away 1 10. We have 1 10 remaining. 2 take away 1 is 1. We are going to be able to spend some time together today working some problems and give you an opportunity to practice what we have just learned. So go ahead and on your personal whiteboard, please show this problem, 46 take away 24. Okay. Go ahead and let's transfer this problem into the written standard algorithm, please, making sure that our place values are lined up correctly. And because this is a subtraction problem, we are going to pay careful attention to the whole. So go ahead, let's draw our magnifying glass so we can carefully analyze the place values in the number 46. On your place value chart, please represent the whole 46 on your chart. We're going to pay careful attention to making sure that our standard problem and our chip model match. So 46. There are 6 ones in 46. 1, 2, 3, 4, 5, 6. Taking care to draw this in a 5-group column. And we have 4 10s. 1, 2, 3, 4. Now we're going to look at the part that we know. Can we subtract 4 ones from the 6 ones that we have? Well, let's give it a try. 1, 2, 3, 4. Yes, we can. We have 2 ones left over. So 6 take away 4 equals 2. Did this problem require us to unbundle any 10s? You're right, it did not, because we had enough ones to take away from. So let's make sure that your chipboard and your standard problem match. And now we're going to subtract in the tens place. 4 take away 2. Let's show that on our chip model. We have 4. We are going to take away 2. We have 2 10s remaining or left over. 4 take away 2 equals 2. And our answer is 22.